Okay, so now we are on activity C, which is evolution. So it says at the top, get the gizmo ready, click reset. So let me click reset. Okay. Set red to 100, green to 255, and blue to 50. Okay, didn't change that. All right, so we're good. You learned in activity B that fit individuals have a better chance of surviving and reproducing than individuals that are less fit, right? And remember, fit doesn't necessarily mean in good shape. It means that they are adapted to their environment, because you could have an elephant that is in great shape and perfectly fit. You put him in Antarctica, he's not going to do really well. Okay. So it's fit means fit for that environment wherever they live. In this activity, you will observe how natural selection affects a population over time. So the question is, how does a population change over time? So the experiment, set the background color to the value shown in the last column of the table below. We use them from the top, but we've already set them. We have 100, 255, and 50. Record the average fitness of generation 1. I've already done this. I got it right here. Generation 1, average fitness is 53. Then move your cursor over the insects and find the individual with the greatest fitness. In first generation, all the insects have the same fitness. Record that individual's phenotype, right? So that would be its color, in the table's third column. So I went here, I clicked on one of these organisms, and the fitness is 53. 53. Okay. So now what we need to do is, it says to move the simulator speed to about 1/4 of the way to the right. Now, I'm telling you, this goes really fast. This is why I'm doing this over again. Okay. You have to run the gizmo and complete the table for each listed generation. Now, the generation doesn't have to be exact, which means that if you don't stop it in time and it's supposed to be 25 and it goes to 27, that's okay. But I didn't stop it in time. It was supposed to be 25 and I didn't stop it till it was like 60. So I needed to slow my roll down a little bit. So we're going to do this and we're going to stop it at approximately generation 25. And there's generation 27. So this is still really fast. This is still really, really fast. So at generation 27, right? At generation 27, so it's close enough. The average fitness hasn't changed much, has it? It's 53. So 53. And then it says to find the one that has the highest fitness levels. So here, there's 58. Let's see, 58. 58. Ooh, 42. That's not good. 58. 58. All right, so 58 is the highest fitness level for all of those organisms. So yeah, you do have to go over each one, right? And then when we found 58, 58 was here. And so we need to put these numbers in again. Okay, so let me go to here. And so we're going to do red is 213, green is 255, and blue is also 255. Okay, and now we need to go to generation 50. 52, not bad. Okay, so average fitness here is 56, so it has gone up a bit. And then we need to go over the bugs and find the one that has the highest fitness. Okay, so far it's 64. Okay, so this guy is the highest one. Okay, you write down his phenotype, right, which tells us what its color is going to be, and you're going to put that here. You're going to go through all of those, and then you're going to answer these questions. How did the phenotype of the fittest individual change over time? Remember, the fittest individual is the one with the highest fitness level. How did the organism change over time? And how did the population's fitness change over time? So the average fitness of the population is here, right? So what trend occurs, right? So then we get down to the process by which populations change over time is known as evolution, right? We call it evolving. This gizmo only demonstrates how one trait, body color, can evolve, right? The body color in these organisms. So now, based on what you have just seen, how do you think the population will evolve if you made the background purple? Okay. So what is your prediction? Don't do it yet. But what's your prediction? If we make the background purple, what do you expect to happen? Right. So what do you expect? So it says to set, they tell you what to set it to purple, and you're going 300 generations, right? So it's going to give you a really good idea of which way the evolution's moving. Okay. Was your prediction correct? Don't just say yes or no. Yes, it was correct because, or it was not correct because, right? The next one is, why do you think it's necessary for there to be variation in a population in order for evolution by natural selection to occur? Why does there have to be variation? Why does there have to be differences for natural selection to occur? Okay. Why is it necessary for traits to be inherited for evolution to take place? And then the last one, this separates the girls from the women, or the men from the boys, or the people that think and the people that don't think. Look carefully at the picture below. You will see an insect called a katydid. Katydids evolved from grasshoppers through natural selection. Use what you've learned to explain how this could have happened. All right. So the bug is right here. Okay, that is the end of our Gizmo adventure for this section. I know it's time consuming, but it's also thought provoking. And it's the closest thing that we can get to hands on while we are in remote teaching. So these are fabulous, even if we're not. But unfortunately, we don't usually have access to them. So I hope you got something out of this, and that you are starting to put some of these concepts together. So take care and have a good night.